Welcome to the project demonstration of MEMS accelerometer control wheelchair. In this project, we are taking one chair which is used to control by the hand gesture, and here we are using MEMS sensor which is AD accelerometer, which is an electromechanical device which will convert the motion of the mechanical movement, and it is converted as electrical, and whenever we change the direction of the MEMS sensor, then it will improve and decrease the resistance, means it will change the voltage value. According to the change of voltage value, we are going to control this robot, which is wired connection, and this connection is given to the PIC6972 microcontroller. This microcontroller will take this input of the accelerometer and give it to the L293D. This is motor driver, which is L293D is used to control the motor directions. This motor direction is controlled by this IC, which is L293, and this is the driver board. And here we are using this motor body, which is parallelly connected motors under this board, and these wheels will be controlled parallelly. These two are connected parallelly and these two are connected parallelly, and whenever we give any signal to one motor, another motor will be controlled parallelly. And here we are using battery supply of 12 volts 1 amp battery, which is connected through switch, and this 2 pin is used to charge this battery, to connect the charger for this battery, and this switch is mainly for giving supply to the whole circuit, and this is the on and off of the switch. And here we are using this charging circuit to charge the battery, and by connecting this to the battery slot now, and this transformer, by giving 230 volts to this transformer, it will step down the voltage to 230 volts to 12 volts, and this voltage is directly given to the circuit. And in this circuit there are two processes. One is rectification and filtration. In this rectification, PN junction diodes are connected in full page rectifier circuit, and this full page rectifier circuit will convert this AC voltage coming from this transformer to DC, which is pulsating DC, and this pulsating DC is given to input to the given as input to the capacitor, and this capacitor will convert this pulsating DC to filtered DC, and this filtered DC will be given to the battery to recharge this battery. And this is a lead acid battery, which having 4 volts 1 amp battery pack, which is 12 volts 1 amp battery pack. In that, one battery having 4 volts 1 amp, like that 3 batteries are connected in parallel, and it will be connected in 12 volts 1 amp battery. By using this switch, the supply is given to this microcontroller and a accelerometer, and this is a LED indication. It's used to mention that this battery is charging now, and if the charging is overload, means it will take 6 to 8 hours. After 6 to 8 hours, the battery power will be repelled and means come reverse to the charging circuit. To avoid that, we are using these two diodes, which are connected in reverse bias, which will oppose the voltage from the battery to charging circuit. Then automatically the charging circuit will be safe. And now let us see the demonstration, and keep this charging circuit whenever the charging is became low, and it will take minimum 6 to 8 hours for charging. And before oning the circuit, put on the gloves on your hand. Be careful, don't touch MEMS sensor, it may lose the contact from microcontroller. Keep it like this, and after that just switch on the, by oning the switch the motor will be on, and here we will have the indication of light, and whenever we bend it forward it will go forward, and when we bend back it will go back. For right it will go right, and for left it will go left. Whenever we bending forward, backward, left, right, it is changing the resistance, means the input resistance of x and y axis will be changed according to the input resistance or input voltage change. Automatically it will be taken as an input to this microcontroller, and this accelerometer is interfaced to the microcontroller to the pins A0, A1, and this L293D is connected to C0, C1, C2, C3, and when we give an input it will be taken from the A0, A1 pins, and this is the main thing. And for forward is a forward and backward, and we should bend some more back to make it backward, and this is left and right. Thank you.